So today we are going to start the next chapter, that is organic chemistry. Now the first question comes here, why do we call this particular branch of chemistry as organic chemistry? Why do we call it as organic chemistry? What was the necessity? Let me go a little bit to history. Actually, in the late 17th century or in the beginning of 18th century, what we find is that organic compounds started known to us. Organic compounds. Like one of the scientists was there, his name was Schille, S-C-H-E-E-L-E, Schille. He prepared tartaric acid from grapes and citric acid from lemons for the first time. That is in the late 17th century, we can say that, 1785 around, we can say. Next, after that, it came, that is, we can say, Roll. What he did is that he prepared uric acid from the urine of the animals. Got it? Then, after that, many more scientists, they came forward. That is, Roll was there, then Santner was there, who prepared, that is, morphine from this, what you can say, organic compounds, we can say that. But all these were naturally occurring compounds. Actually, the term organic chemistry was given by Berzelius. Got it? What I said his name? Berzelius. The term organic chemistry was given by Berzelius. Now, why he called it as organic chemistry? That is the first question I asked you. Why he called it as? Organic chemistry has come from the word which means that these compounds are derived directly or indirectly from the organs of the plants and animals. Again I repeat, Berzelius termed it as organic chemistry. The reason was that these compounds are derived directly or indirectly from the organs of the plants and animals. For example, I said you, like acetic acid we are getting from vinegar, we can say that. Schille got tartaric acid from grapes, citric acid from lemons, we can say that. Next, we know that we are getting what you can say, a Roll he prepared, that is urea from the urine of the horse and animals. Got it? So in this way we came to know about the organic chemistry. Got it? And hence we got the term organic chemistry, we can say that, because these compounds are derived directly or indirectly from the organs of the plants and animals. Okay, fine. Now, we at that time, at the beginning of this 18th century, when certain organic compounds was known to us, as I said, citric acid, malic acid, tartaric acid. Malic acid we are getting it from the apples. Got it? So then after that, vinegar, your acetic acid. Got it? And in this way, few compounds like urea and all was known to us. So the people believed that organic compound could not be synthesized in the lab. Whatever is available in the nature, we have to satisfy with that only. Why? Because they believed there was a peculiar kind of force which was present in organic compound, which is known as vital force. They believed, at that time, the people, they believed, the scientists, they believed that there was a peculiar kind of force present in organic compounds, which was known as vital force. And that gave us a theory also, which is called as vital force theory. According to this theory, it is being believed that in case of organic compounds, the bond is very strong, it is very unique, it is so peculiar that we cannot break that particular bond, and hence it cannot be synthesized in the lab. We cannot synthesize, we cannot prepare this organic compound in the lab. So that was a belief, again and again I am saying that's a belief, it was there. And they set up this theory which is called as vital force theory. Got it? Now, this belief persisted unless and until, that is, Friedrich Wöhler. What I said? Friedrich Wöhler. W-O-H-L-E-R. Friedrich Wöhler. He was a German chemist. He was a German chemist who accidentally prepared urea in the lab. Why did I use the word accidentally? Because he was not preparing urea. He was actually distillating two compounds. Accidentally he prepared urea. Alright. Now what was that particular distillation process? Let us see that. So Friedrich Wöhler, he was a German chemist who accidentally prepared urea in the lab. Now, for your general knowledge, let me tell you. In Germany, so to say, there are two, names are there. One is Rudi Wöhler, another is Friedrich Wöhler. If you are having some interest in football, you must be knowing that Rudi Wöhler, he was called as a header. He was a famous football player from Germany. We can say that. Like Pele is there from Brazil. He was a famous football player from Germany. That is Rudi Wöhler. Alright, Wöhler, V-O-E-L-E-R, Wöhler, that was. He was also a German. So don't confuse. If you are having some interest in football, you must be thinking of that particular Wöhler. No, not at all. He is Friedrich Wöhler. For that reason, I said this particular one because one of the students asked me once. So that Wöhler we have heard of. Yes, that's a Wöhler. It's a very famous person. But he was a footballer. But he is a chemist. Both are from Germany. Alright, remember it. So what I said, he accidentally prepared urea. Actually, he was distillating two compounds. What was that? He took ammonium sulfate or ammonium chloride. Anything you can take it here. Ammonium chloride or ammonium sulfate. Anything. And potassium cyanate. What I said? Potassium cyanate. He went for, what is that? Distillation of these two compounds. He went for distillation. So what will get it? It is a double decomposition process. You know that distillation is a double decomposition. So KCl plus, what is that? NH4CNO. NH4CNO. See here. KCl. It is KCl plus ammonium cyanate. This is called as ammonium cyanate. Ammonium cyanate. Now, ammonium cyanate is an unstable compound. It's unstable. It's not stable. So, what will happen is that ammonium cyanate will undergo molecular rearrangement. Molecular rearrangement to give urea, NH2CO, NH2. You can see molecular formula is the same. See there. Here, how many nitrogen? 2 nitrogen, 4 hydrogen, 1 carbon, 1 oxygen. Here also 2 nitrogen, 4 hydrogen, 1 carbon, 1 oxygen. So what is this? This is urea. We can say that. NH2CO, NH2. So in this way, urea was prepared accidentally. Wöhler was not preparing urea. What he was doing? He was distillating these two substances. And hence he got urea. So what I said to you? The molecular formula is the same of these two compounds. Alright? But the structural formula is different. Here this is unstable. This is quite stable in nature. So what do we call it as? These are known as isomers. You have studied in the lower classes. It is known as isomers. Isomers are the compounds having the same molecular formula but different structural formula. Again I repeat. Isomers are the compounds having the same molecular formula. You can see the molecular formula is the same. Here 2 nitrogen, 4 hydrogen, 1 carbon, 1 oxygen. Here also same thing. Having the same molecular formula but different structural formula. So in this way they are the isomers. So after that, many more scientists they came forward. Like what you can say, Berzelius was there initially. Then after that, Kekule came forward. Then after that, Kolb came forward. Then after that, what you can say, this Ladenburg came forward. In this way, many more scientists they came forward and they prepared one after another compound. Alright. So due to that reason, vital force theory got a great setback. Alright. When many more compounds was being prepared in the lab, then the vital force theory got a serious setback and this particular concept was discarded. It was being completely outright discarded, this particular concept, because vital force believed that there was a peculiar force for which we are not what you can say, going to synthesize organic compound in the lab. But here you can see we are able to synthesize it. We are able to prepare it. Urea was prepared. After that, acetic acid was being prepared in the lab. Alright, acetic acid is being prepared. You know how acetic acid is prepared? I will tell you how acetic acid is being prepared. Alright, in the lab. So, how it is being prepared? When carbon reacts with hydrogen in presence of electric spark to give you acetylene, C2H2. Alright, acetylene reacts with water in presence of HgSO4 and H2SO4. Mercuric sulfate and sulfuric acid. Here it reacts with water to form what? It undergoes addition reaction to form CH3CHO, acetaldehyde. C2H2 reacts with water. You learn this particular reaction when I will teach you alkynes. This is what? Ethyne, this compound is known as, or acetylene. When I will teach you acetylene, I will teach you this particular reaction, that how it's taking place. Now, for the timing, just you understand it. I am just telling you how acetic acid is prepared. Got it? So in this way, carbon and hydrogen, when reacts in presence of electric spark, under high temperature, it gives acetylene. It undergoes an addition reaction. And here it undergoes what you can say also addition reaction, same thing. That is acetylene. Acetylene is nothing but HC triple bond CH. You can write it in this way also. You can write C2H2 or you can write HC triple bond CH. We can say that. All these things you are going to study. Just you have started the chapter. So don't worry, listen patiently. So reacts with HOH in presence of sulfuric acid and mercuric sulfate. That is your acidic medium to give acetaldehyde, which further goes oxidation. This is nascent oxygen to give you what? That is nothing but acetic acid. That is called vinegar. In this way, vinegar was being also prepared. Clear? In this way, what you find is that more and more compound was being prepared by what I can say, that is nothing but Kolb. It was prepared by that's Ladenburg. It was prepared by many more scientists that prepared it, this particular one. Clear? Then after that, Lavoisier. You have heard this word, Anthony Lavoisier, in the first chapter. Anthony Lavoisier, he came forward and he said that this particular compound, which organic chemistry, he said that it developed a new concept, and he gave this particular branch of chemistry the new term. What is that? It is now known as hydrocarbons. Hydrocarbons. It is now known as hydrocarbon. Who said this? Lavoisier. Lavoisier said that this branch of chemistry is no more organic. Why? Because organic means it is derived from the organs of the plants and animals only. But now we can see that we are able to synthesize in the lab. So definitely the concept has changed. And hence he introduced the term which is known as hydrocarbons. So what is hydrocarbon? Hydrocarbons are the compounds of hydrogen, carbon and its derivatives. Hydrogen, carbon and its derivatives, whose general formula is given to be as CXHY. We can say that X and Y are any natural numbers. We can say that. Clear? So in this way, he said us that a new concept has built up, which is hydrocarbons, a compound of hydrogen and carbon and its derivatives. Derivatives means oxygen will also be added, chlorine can also be added, sulfur can also be added, nitrogen can also be added, phosphorus can also be added in this way. But the major component is what you can say, carbon and hydrogen. So hence he called it as hydrocarbon. Alright. So from that onwards, today we are saying also organic chemistry as a study of hydrocarbons. We can say that. But still many of the people, they use the old term, that is organic chemistry. Hence I wrote it as organic chemistry. So this is a brief history I have given it to you about organic chemistry. Thank you very much.